Okay, so we're going to work through a few problems here using Ohm's law to solve some basic voltage source and resistance circuits. How I usually start is just writing the formulas up on the top corner here. So we have V equals I times R, I equals V over R, and R equals V over I, where voltage is represented by the letter V, current by the letter I, and R for resistance. Okay, so let's start with the basic circuit here. And usually in these circuits, we're given two of the variables. We have to solve for a third one. So, for example, we might have voltage equals some value, R equals some value, and I equals some value. And let's start with a very basic circuit where we have a voltage of 6 volts and a resistance of 2 ohms. So usually what I ask people to do is draw the circuit to get an idea of what it looks like. Usually when we're drawing a DC voltage source, we draw it as a schematic symbol for a battery. You may see some other symbols, but that's a common symbol that's used. And since the voltage is 6 volts, we'd write 6 volts here. And we might have a name for this voltage source, for example, V1. Next, we're going to draw the resistor in the circuit, drawn like that. And in this case, the resistance is equal to 2 ohms. And we'll call it R1. These naming conventions become more important as we add more components into the circuit. The current, because it's not a component, is typically shown as like an arrow here, for example, like this with the letter I. And this is the variable that we're solving for. We don't know what the current is. So in this case, if we're solving for current, we want to use this formula up on the top right. In the corner here, I equals V over R. So if we write this out, I equals, we simply plug in the values for voltage, in this case 6 volts, and the resistance is 2 ohms, divided by 2 ohms, and we get an answer of 3. The question is, what are the units? Well, with current, we're working with amps, which is short for ampere. So we'd write this as 3A, and that would be our final answer here. Now, because these are what are called ideal values, there are no significant figures that we're really working with, so we'll simply write it as an integer value. I'm going to also ask that you box in your answers when you do your homework, so it's easy for me to kind of spot what your final answer is. For our next problem, what we're going to do is still solve for current. But in this case, we're going to change the units to look a little bit at these engineering units that we talked about last week or the week before. So in this case, let's say our voltage is 9 volts. Okay, so we'd write V1 is 9 volts. And in this case, the resistance is going to be 100 ohms. I'm just picking these values out of my hat here. 100 ohms. And we're trying to solve for the current here. So again, we're going to use the second formula here. I equals V over R. And we're going to write it out. I equals 9 volts divided by 100 ohms. And if we solve for that, we get a value of 0.09 amps. Sorry about that. I was trying to get my marker working there. Now, if you'll remember, that is not an example of something that's written in proper engineering units. We want to change this into engineering units, and because we don't have any numbers in front of the decimal point, we're going to shift the decimal point 3 places. So let's take a look at what that looks like. 090. I'm going to move the decimal point in this place, in this situation, 3 places. 1, 2, 3. So our final answer is going to be 90, but because we've moved it 3 places to the right, we're moving to smaller units, so we write that as 90 milliamps. And that's our final answer. Now let's pick a problem where we're solving for resistance. So in this case, we're going to start with a 10 volt source, and we're going to be given a current, in this case 5 milliamps. Now, if you remember, that milli prefix refers to 10 to the minus third. So in reality, we'd write that if we're punching it into a calculator, typically something like this, 0.005 amps. So it's important to keep track of that. You can't just plug in the number 5. We have to make sure we're working with the proper orders of magnitude. So in this case, we have 10 volts here. Our current is 5 milliamps in the circuit, and we're trying to solve for R. What is R in this case? So in this situation, because we're solving for resistance, we'll use this formula here, V over I. So R, in this case, is going to equal V over I, which is 10 volts over 0.005 amps. Now on your calculator, you could certainly plug in, for example, 5 times 10 to the minus third. That would be fine. And if we calculate that out, that ends up being a value of 2,000 ohms. But is this in engineering units? And the answer is no. We have more than 3 digits in front of the decimal place. So we'll write this, and using the letter abbreviation K for 1,000, we would write this as 2K ohms. And that would be our final answer. For our third problem, we're going to solve for voltage. So in this case, we don't know what the voltage is, but I'm going to give you a value here of 500 ohms for R1. So we'd write that down here, 500 ohms. The current in this case is going to equal 10 milliamps, okay, which is 10 times 10 to the minus third. So again, we draw that as an arrow here and write, for example, 10 milliamps. Okay, to solve for this now, we're trying to find out what the voltage is. So in this case, we're going to use the formula on the top. V equals I times R. So we're going to say V equals I, which in this case is 10 milliamps. We'd write that as 0.01 amps times, in this case, 500 ohms. Okay, and if we multiplied that through, we'd end up with a value of 5 volts. Now, in this case, if you accidentally put the number 10 in there instead of 0.01, you'd end up with this really, really high voltage. We'd end up with 500 volts. And that isn't really a reasonable value for this answer. So you always want to check and make sure that your units look reasonable. And also, if I'm asking for voltage, make sure that the answer that you're writing is in units of volts. Sometimes students I'll ask them to solve for resistance and they'll write the units in volts or milliamps. So always make sure to double check that. Okay, so that's an example of some of the basic Ohm's law calculations we'll be doing.